Hey guys, what's going on? Today I'll be going over linked list cycle 2, and if you haven't seen my video on linked list cycle, then I encourage you to go back and watch that before watching this video. And in this problem, you're given a linked list and you have to return the node where the cycle begins. So this is different from the regular linked list cycle problem because in that case you just had to return a boolean true or false whether a cycle existed or not. So how should we go about tackling this problem? Well, we could just traverse the linked list and store each node inside of an array, and then once we get a repeated node, then we know that there is in fact a cycle, and then we can determine where the cycle began. So we want to actually solve this problem with O of 1 space complexity, and we can do that by using Floyd's Tortoise and Hare algorithm. So in this algorithm, we have two pointers, a fast pointer and a slow pointer. The slow pointer will increment by 1 node every time, and the fast pointer will increment by 2 nodes every time. And if you keep incrementing these nodes, they'll eventually intersect at one point. So let's just go through this, and we see here, slow moves up by 1, fast moves up by 2, and then we go to the next step, same thing, and then the next step, that's where it actually intersects. So what I basically went over was the linked list cycle algorithm, but this is linked list cycle 2 where we have to find the actual position of the node cycle beginning. So what we want to do at this point is to reset one of these pointers back to the head. It doesn't matter which one, you can either do slow or fast. We have that here, and now we want to increment each pointer just by 1 step. And if we do that, we'll eventually get to the point where the slow and fast are pointing to the beginning of the cycle. So the reason why this works is because the fast pointer is always going to travel twice the distance as the slow pointer. So if we reset one of the pointers to the beginning and just increment them by 1, we'll eventually get to the point where they're both pointing to the beginning of the cycle. And there's a lot of math that you can do to prove this, and I'm going to put a link in the description if you want to check that out. But I'm going to just jump right into the code right here. And so the first thing we do is declare the fast and slow pointer here. They both start at head, and we have this while loop that just loops through and increments the slow and the fast pointer. And then in the event that the slow pointer is equal to the fast pointer, we break. And at that point, we know there's a cycle. And then we have this case here to check if not f or not f.next. So what does this mean? This means that this loop actually broke, and it broke because either there was f is equal to null or f.next was equal to null. So in which case we know that there's no cycle in it and we can just return none. In other words, it means we've reached the end of the linked list. So now we put the slow pointer equal to head, and again, we can do this with the fast pointer as well, but I just chose the slow pointer, and then I did while slow pointer is not equal to f, we just increment the slow pointer and the fast pointer. And then at the very end, we just want to return the node where it's at. So this while loop is going to break at the point where s is equal to f, and then we're just going to return s, which is the slow pointer. Or you could do f. Either one works. The runtime of this is actually very simple. It's just O of n because you're just looping through, traversing the linked list, and the space is O of 1 because we're not allocating a new array or anything like that. And if this video helped you out, be sure to leave a like and consider subscribing. Thanks for watching, and I'll see you guys in the next one.